talk about the derivative today. I know a lot of you guys have heard this because it is a big thing in calculus. Okay, so we're going to be talking about what it is and how to find it. You guys already actually know how to find it, and you actually already know what it is. You just might not have known that this is what it's called. The derivative basically tells you the slope of a function at a specific point. That's what a derivative is. It tells you the slope of a function at a particular point. And that's actually what we've been doing in 2.4 or whatever section it was. The last section we dealt with, all we were looking for was the slope of whatever function at a specific point, at a specific time. Are any questions with that? So the derivative tells you what the slope of a function is at a specific point. That is the formula, kind of, to find your derivative. And if you look at it, it should look pretty familiar.
Is there supposed to be an apostrophe thingy?
Yeah, I'm going to talk about that in a little bit. So this apostrophe thingy, this stands for the derivative of f of x. The derivative of f of x. So the derivative of a function is equal to this. And this is the same thing we were talking about last time. Right? The formula is the same. The only difference is instead of it being a, it's x. But it doesn't really change anything. It doesn't really change the calculation involved. Okay, and hopefully you guys already have this memorized. And most of you guys did. Okay, any questions with this? Anyone still copying this down? Alright. So we're going to differentiate, which means find the derivative of this function. We're going to differentiate, which is the same thing as find the derivative of this function. Now I know a lot of you guys are able to do this on your own, but we will go over this, just in case you forgot by Friday already, or since Friday. Okay, so the very first step is to write down that formula. But if you haven't gotten it memorized, write it down each time. Even if you do have it memorized, if you're a little shaky about it, if you can't do it quick, I would write it down first. Okay, when I do these problems, I still write it down because it's just that much more helpful. It helps prevent me from making any mistakes. So the x plus h, we plug it into this function. The x, we plug into the function here. So we have the limit as h approaches 0 of x plus h cubed minus x cubed over h. Alright, and then we're going to simplify this. We're going to multiply this out. So we have x plus h times x plus h times x plus h. X plus h squared is this right here. And I don't think anyone made a mistake on that step of the test because there's a question that's very similar to this. When you guys distributed these two parentheses, when you guys multiplied it along with the other stuff here, a lot of people started making small mistakes there on that last word problem. Okay, so distribute your x. So x times that. So x times all of those. H times all of those gives you that, and you can't see that. So let's see. Okay, any questions so far? So, I mean, you can copy this down if you want, but you really should be able to just multiply it yourself and get the exact same thing. It's the same thing up there. Alright, so with something this complicated, I know when you first learned Algebra 1, you know, they tell you to cross stuff out as you're simplifying it and as you rewrite it to help you keep track of what. I bet a lot of you guys don't even do that anymore because, you know, you can kind of keep it in your head. But with something so complicated, it really is worth it to just cross things out as you start simplifying it so you know exactly what you have left. So the x cubed minus x cubed will cancel out. 2x squared h plus x squared h will give you 3x squared h. Xh squared plus 2xh squared will give you 3xh squared. And then you got the plus h cubed left over. All over h. Okay, any questions there? Okay, but double check that, make sure you didn't make a mistake. Yeah.
Do you put the h to the third in the front because it has the highest?
Sure, you could. Yeah, probably should do that.
But it wouldn't make a difference.
No, it's not going to make a difference in the end. Yep.
Should we take out the h's?
Yeah, so now we're going to factor out the h's. Or one h from each term. And then we simplify them. And then we have that. Okay, from here, what do? Hey, you plug 0 into h. So, you plug 0 into h, and then you simplify it.
How did you get the x or h?
Here,
No.
here, that one.
Yeah.
You add 2xh plus
Oh.
x squared h. So you add these two together to get that. Okay, so the derivative of x cubed is 3x squared. Yeah. So this means, so that's like a apostrophe. It's not really a 1. This means the derivative of the function. So f of x is the function with the apostrophe in there. It's the derivative of the function.
Well, apostrophe means derivative.
Huh?
Apostrophe means derivative.
Yeah, basically. Okay, any questions so far? So, I mean, it's very similar to what we were doing before. And so this really should not be new, except for maybe the apostrophe.
Okay, so what's the difference between that and what we were doing before?
There is none.
What is that?
Yep. So we were already doing the derivative before. You just didn't know it yet.
Just put a title on it?
Yeah. Okay. Questions so far? Anyone some comments down? Okay, try this. Do the same thing. Okay. So this is going to be your answer. Keep working, but let's see. It's going to be 1/2 x negative 1/2. So it's going to be 1 over 2x. Yeah. So that's your answer right here.
Wait. See this?
You never explained this to
See
me.
this?
It's cheating.
I know. I'm just giving you the answer first, so you know if you're right or not. I'm gonna go over it.
Oh yeah. I already know what you're gonna say. Dude, I already know what you're gonna say. Yeah, I already know what you're gonna say. You said it before. So.
Yeah, I know.
All right. Anyone get that answer?
Right.
Great. You want to try? You want to do it on the board?
No.
Yeah, do it on the board.
You can do it. Yeah, better.
Okay.
Right.
Well, I'm gonna try to find a marker that works for it.
You can do it. It's instructed right out there.
Jake, after the tea.
Okay, so only one person got this right so far.
Who was that?
Parents. Just hide the parents.
Okay.
Oh, I missed it.
Hey, oh, this is the whole.
Okay, here we go.
Oh, yeah, okay.
So first thing we're going to start with is the formula. Right? Is that okay there so far?
Dude, I think I'm gonna have to bet handwriting. I know that.
Okay, and we're going to plug that into the square roots. So we got the square root of x plus h. Can you guys see that or no?
I can see.
Dude, well, that's not bored.
Okay, and then minus the square root of x over h. Okay. How many of you guys are stuck here? Okay. So what you have to do whenever you're dealing with square roots is you're going to have to multiply by the conjugate. If you ever don't know what to do and square roots are involved, multiply by the conjugate. That's normally the next step. What's the conjugate here? What are you going to multiply by?
Square root of x plus h plus square root of x.
Yeah, so it's the same thing as your square root parts,
Gotcha.
but the signs are different. So you're going to multiply by square root of x plus h plus square root of x over square root of x plus h plus square root of x. And then you are going to FOIL. Okay, so try it from there now.
No, I can't see it.
Okay, when you multiply, you should get this right here. Let's see. X plus h.
I know, but you know, I'm just making sure.
That'll cancel out.
Good.
Minus x over square root of h x plus h plus h square root of x. Everyone okay there? Any questions? Okay, we can simplify the top. The x's will cancel out, so we get h by itself up top. What can we do with the bottom?
Bring up h.
You can what?
Quick and
You cancel out to 0, because you're going to get 0 plus 0. Yeah, you can factor out the h.
I thought it was gonna be when I plugged in h, I was like 0 over 0. I was like, no, it's not. It doesn't make sense.
Okay, any questions there? And then the h's cancel out, obviously. Now you can plug 0 in for h. Because remember, it's still a limit, right? I'm just not writing each time. And then you get 1 over square root of x plus square root of x, which is 1 over 2 square root of x. Which is how I got that. Positive.
I thought when
One
something
negative.
cancels out, it turns into 0.
Yeah.
I thought when something cancels out, it turns into 0.
No. Because we really have h divided by h, right?
So,
So it's 1. Alright, any questions there?
So every time it's a square root, we just multiply by like.
If there's nothing else you can do, yeah.
So you were supposed to do on the test too, huh?
Yep.
Wait, say that one more time?
Every time there's a square root, we just multiply by.
Well, kind of, on the extra credit.
That's what you were supposed to do on the test.
Okay, any questions? Anyone not know where I got any of these steps from? So, the calculus part really only happens here. The rest of this is really just the algebra. Because all you're doing is plugging in stuff and simplifying. Okay, any questions?
Exactly what you said.
Okay. Now, there are different ways of showing derivatives. I don't know why, or I kind of know, but not really, why there are so many different ways. But they all mean the same thing. Let me erase this. Okay, so there's a lot of different ways of writing derivative, because we're not going to write, the word each time. That's just silly. So we're going to use different notation. So the first one you already seen is f apostrophe x. Now when we say this though, we don't say f apostrophe x. We just say the derivative of f of x or f prime of x.
Oh, that's what I find.
Yeah. So f prime of x. Okay, so f prime of x. F of x is the same thing as y, right? So sometimes we'll use y instead. And then we'll have y apostrophe. We call that y prime. Right, and prime is just derivative. So we got f prime, y prime. We have dy dx or dy over dx, but when we talk about this, we always just say dy dx. This just means the derivative of y in respect to x. And it sounds more complicated than it actually is, but it's just a derivative. Dy dx. So when it says find dy dx and it gives you a function, you're looking for the derivative of something. We have df over dx because y and f are a lot of times the same thing. And then the last one is d over dx of f of x. Now these all mean the same.
Which ones were common?
There are 3 of them that are common. One of them that people still use sometimes, and one of them I rarely ever see.
Which one would they most likely use?
So these 3 they use all the time.
Like on the exam?
On everywhere. Exam, book. Yeah. Exam and book. Well, everywhere. Any calculus class uses those 3 probably the most.
Why can't they just
I don't know. And then this they probably use they still use this also. And then this I don't really see that often. But if you do see it, that's what it means. That's it then. I know. Well, I can keep going if you want, but yeah. So, your assignment's page 105. If you haven't noticed, the top of each assignment page always has a review section. We're going to start doing some of those just so that you don't forget previous stuff. So do the review problems 1 to 9 odds, and then 1 to 11 odd. And it's going to be basically what we were just doing in class today.